All right, now we're going to start with our testing procedure. The first test that we're going to talk about is for chlorine. When we talk about chlorine, there's some important things to understand. When you hear the term chlorine, there's three different types of chlorine that you commonly hear referred to. The first type is what's called free chlorine. Free chlorine, regardless of what type of chlorine you're using, liquid chlorine, tablet chlorine, powdered chlorine, free chlorine is when you add chlorine to the pool. It's free chlorine. It's free and available and ready to do its job. Free chlorine is good chlorine. That's the chlorine that we want to have in the pool. Now in the state of Rhode Island, in a commercial facility, the range that you're allowed to have free chlorine in is dependent upon whether it's a pool or a spa, whether it's an indoor facility or an outdoor facility. And if you check out your test logs, that again we have a link to on our website, they'll show you. So for an indoor pool, you can have as low as 0.7 parts per million of free chlorine and as high as 2 parts per million of free chlorine. And an outdoor pool, you can have from 0.7 to 3.0. Now in a hot tub, the range, indoor or outdoor, it doesn't matter, goes from 1 to 5 parts per million. And all that's on your log sheet. So the first thing we're going to test for is free chlorine. That's free and available, good chlorine that's ready to do the sanitizing that needs to happen in the pool. The second type of chlorine that you hear about commonly is what's called combined chlorine. And combined chlorine is essentially used up chlorine. Combined chlorine is bad chlorine. It's no longer available to do its job. And in fact, combined chlorine, the other word for it is chloramines, and that is what's responsible for a lot of the bad rap that chlorine gets. It's not free chlorine that causes the problem, it's the combined chlorine. Combined chlorine is used up. And combined chlorine is what causes skin irritation, eye irritation, the red eyes, that smell of chlorine. It's not actually chlorine, it's used up chlorine. The chemical reaction that takes place is when you put chlorine in the pool, it's free chlorine. It's free and available and ready to do its job. That free chlorine molecule bonds with a molecule of dirt or bacteria or what have you, and it forms the combined chlorine. At this point, it's used up. It's not doing anything good in the pool. In order to get rid of the combined chlorine, you now need a second molecule of free chlorine to come in, combine with the combined chlorine. It has an oxidation reaction, it gives off a gas, and it's out of the pool entirely. So from a practical standpoint, if you always have enough free chlorine in the pool, 2 molecules for every molecule of dirt or bacteria or whatever that you're trying to sanitize, you'll never have a problem. The free chlorine makes the combined chlorine, another molecule comes in, it combines with the combined, it gives off a gas, and it's out of your pool. The problem comes in if you have just enough free chlorine to make the combined chlorine, but not to get rid of the combined chlorine. Now you have a combined chlorine problem, and that's the pool that smells like chlorine. You walk into the hotel, you walk into the fitness club, and you smell chlorine. You're not smelling chlorine, you're smelling used up chlorine. The problem is it's counterintuitive. The average person smells chlorine in the pool and they say, oh, the chlorine's too high, I need to stop adding chlorine, which is exactly the opposite of what needs to happen. At that point, you need to add chlorine into the pool to make sure that you get rid of that combined chlorine. But because it's counterintuitive, people don't know that. So many facilities have a combined chlorine problem, and the way to resolve that is to add more free chlorine. The state guidelines, regardless of whether it's a swimming pool or hot tub, indoors or outdoors, the maximum permissible level of combined chlorine is 0.2 parts per million. So you ideally want 0. Anything above 0 is a problem, but you can go as high as 0.2. So that's the second thing we're going to be testing for, is combined chlorine. The last term that you sometimes hear with chlorine is what's called total chlorine. Total chlorine in and of itself is not really anything. Total chlorine is just a way to figure out how much combined chlorine you have. There's some test kits that can only test for free chlorine and total chlorine, which is free chlorine plus combined. They don't have a direct way to test for combined chlorine, so they have this term total chlorine, which means free chlorine plus combined equals total, because that's all the kit can test for. In that situation, if you have that type of test kit, you want your total chlorine to be the exact same as your free chlorine, which would indicate that you have 0 total chlorine. This test kit, unlike some of the other ones, can actually test for free and test for combined, so we don't worry about the total, because the total is sort of a made-up term anyway. It's just a way to get to the combined chlorine. So the 2 things that are required for state testing are free chlorine and combined chlorine, which we're going to be testing for here today. So we're going to take our comparator tube, and on this test kit, the instructions are right on there, but sometimes it's very difficult to understand what they're saying. So that's why we're doing this demonstration. I'm going to explain to you what you're looking to do. So on this tube, there's two different marks, a 25 milliliter mark and a 44 milliliter mark. The test kit gives you the option of either filling the sample tube to the lower mark or the higher mark. If you fill the sample tube to the lower mark, when you do your testing, it's going to register in increments of 0.5 parts per million. The upper mark, if you do that testing, it's going to register in increments of 0.2 parts per million. That's what we want to go for. We want precision here. We're looking to get the precise test result, the most precise test result that this kit can give us. And 0.2 is much more accurate than 0.5. So that's what we're going to do. We're going to fill the comparator up to the higher level so we get a 0.2 test. So what we do is, as we said in the previous section, take a sample of water from at least 12 inches below the surface of the pool, and then we're looking at our comparator and making sure that the water is filled exactly to the line. If it's not, we're going to either add more or pour out a little bit. And with water, there's a meniscus when you put it in a tube. We're looking for the bottom of the meniscus to be on that line. That's exactly where we want it. So you want to look at it on level and make sure the meniscus is right on that line, which in this case it is. So now with this kit, what we're going to do is we're going to take this powder, which is R870. And you never want to be dealing with the reagents when your hands are wet. So if you've taken the sample and your hands are wet, you want to make sure you dry them. If you touch the powder, touch the reagents with wet hands, that's going to potentially clog it up. So we're going to take the lid off. Now this is going to call for 2 scoops, 2 level scoops of this powder, the R870. Okay. Whenever you're done with the reagent, you always close the lid. If you leave that over to the side, it spills. If you get water in there, it's not going to be good anymore, so you always close it up right afterwards. So, if there's chlorine present in the water, it'll turn pink. And sometimes you have to do a little swirl to make sure that everything dissolves properly. Now, I put a little bit of bleach in this tub here to make sure that we had a sample that we could read. So we have a nice bright pink color with that after putting the powder in. The next thing that we're going to do is we're going to put our drops of R871. And at this point, what we're looking to do is change the sample from pink to clear. That's the indication of how much chlorine is in this water. And we're going to count our drops as we put them in. So first drop, swirl, second drop, swirl, third, we're 6 drops in now. Starting to turn, but it hasn't fully turned. 7, 8, 9, 10. I'll give it a good swirl now. So with just that little splash of bleach, this is pretty high. We're already at 10 drops. And what we're going to do to calculate this is when this turns clear, we're going to multiply the number of drops that we've added by 0.2 because we filled it to the upper line. So it's at a 0.2 increment. So 10 drops times 0.2, we're at 2 parts per million right now. 0.2 times 10, 2 parts per million, and we still haven't changed yet. So if this was an indoor pool, we'd already be over. All right, so that's 30 drops, and we still haven't changed. So that's an indication that we're way over the acceptable limit. If this was a pool, it would fail because we're beyond that. 30 drops times 0.2 gives us 6 parts per million, which is very high. It's beyond even the range for a hot tub. At this point in time, on your regular pool, if you had tested it, this would have turned clear. And when I say turn clear, I don't mean start to turn clear and then go back to sort of pink, fully turn clear. When it fully turns clear, that's when you're done with your testing and you can multiply the number of drops you added by 0.2 to get your actual reading. So let's say that we had done this, we added 20 drops times the 0.2, that gives us a free chlorine reading of 4.0 parts per million. So then we record that on our sheet for the pool or for the hot tub, depending on which body of water we're testing.